deep beneath the surface of the Earth, forces are stirring. Scientists have been monitoring an increasing number of warning signs: earthquakes swarming in ominous clusters, ground deformation stretching across miles, and gases leaking at alarming rates. These aren't just random geological quirks, they are signals, hints that something massive is brewing beneath our feet. A supervolcano, one of the most powerful natural forces on Earth, could be preparing for an eruption, and the consequences would be catastrophic. The sheer scale of what we're dealing with is difficult to grasp. Unlike a regular volcano, which might produce lava flows or spew ash into the sky, a supervolcano doesn't just erupt, it explodes with a force thousands of times greater, reshaping landscapes, altering the climate, and threatening the very fabric of human civilization. The last known supervolcanic eruption occurred over 26,000 years ago, and if history is any indicator, the planet is overdue for another. Scientists have identified several potential supervolcanoes around the world, with Yellowstone in the United States being the most infamous. Beneath the picturesque landscapes of the national park, an enormous magma chamber stretches for miles, filled with molten rock and building pressure. Over the years, researchers have detected rising heat signatures, shifts in geothermal activity, and even instances where entire sections of land have lifted by inches in a matter of months. While an eruption isn't guaranteed to happen soon, the possibility is real enough to have experts concerned. A supervolcanic eruption wouldn't be just another natural disaster, it would be a global event. The initial explosion would be incomprehensibly powerful, blasting ash and rock into the atmosphere with enough force to darken the skies worldwide. Entire cities within hundreds of miles would be buried under layers of volcanic debris. But the most devastating effect wouldn't come from the eruption itself, it would come from what follows. The vast quantities of ash and sulfur dioxide released into the stratosphere would form a thick layer, blocking sunlight and triggering a volcanic winter. Temperatures would plummet, crops would fail, and supply chains would collapse. The world relies on a delicate balance to keep food production stable, and a sudden shift in climate could lead to mass starvation and geopolitical chaos. History has already given us a glimpse of what this could look like. In 1815, the eruption of Mount Tambora in Indonesia caused what became known as the year without a summer. Ash spread across the globe, temperatures dropped dramatically, and agricultural failure led to widespread famine. But that was a mere fraction of what a true supervolcano is capable of. Today, with a population of over 8 billion people, the impact would be exponentially worse. Modern infrastructure is fragile in the face of such large-scale disruption. Supply chains rely on predictable weather patterns and stable conditions, and a sudden volcanic winter could collapse entire economies. Global trade would grind to a halt. Crops would fail not just in one region, but across continents. Nations would scramble for resources, and tensions could escalate into outright conflict as societies struggled to survive in the wake of environmental devastation. And yet, despite the immense risks, there is no real global plan in place to mitigate the effects of a supervolcanic eruption. Unlike asteroids, which NASA and other space agencies actively track and prepare for, supervolcanoes remain a vastly underprepared threat. Scientists have long warned that a catastrophic eruption is not a matter of if, but when. And when that day comes, the world may not be ready. Research teams continue to study the underground magma chambers, using satellite imaging, seismic sensors, and geochemical analysis to try and understand the behavior of these ticking time bombs. However, predicting the exact timing of an eruption remains an enormous challenge. Volcanic systems operate on timelines far longer than human lifespans, and many of the indicators we rely on, like earthquake activity and ground deformation, can fluctuate without leading to an immediate eruption. That means the warning signs we do see might not indicate an eruption tomorrow, but they also can't be ignored. The problem is that the scale of preparedness required is massive. Evacuation plans for an event of this magnitude would need to be global, spanning multiple countries and continents. Food reserves would need to be stockpiled on an unprecedented level. Alternative agricultural solutions would need to be developed, perhaps even including underground farming or artificial food production. And yet, despite all this, little has been done to prepare. Some scientists are exploring radical ideas to mitigate the effects of a supervolcano before it erupts. One concept involves drilling into the magma chamber and extracting heat to slowly release pressure, preventing a full-scale explosion. But this approach carries its own risks. Tampering with a volatile system could inadvertently trigger an eruption instead of preventing one. Others propose using aerosols to artificially reflect sunlight and counteract the cooling effects of volcanic ash. But such geoengineering solutions are controversial and untested on a large scale. The truth is, there may be no easy solution. Humanity has never faced a supervolcanic eruption in recorded history, and the scale of destruction is difficult to fully comprehend. The best scientists can do for now is continue monitoring, gathering data, and sounding the alarm. And as we look ahead, the question remains, will we listen? The truth is, there may be no easy solution. Humanity has never faced a supervolcanic eruption in recorded history, and the scale of destruction is difficult to fully comprehend. The best scientists can do for now is continue monitoring, gathering data, and sounding the alarm. Even if an eruption doesn't happen tomorrow, the risks remain ever present. Beneath the surface, magma continues to accumulate, pressure builds, and the delicate balance that has kept these massive systems dormant for thousands of years could shift at any moment. Some researchers warn that smaller volcanic events may provide clues. Earthquakes occurring in unexpected locations, sudden steam releases, or even minor eruptions could signal the early stages of a much larger disaster brewing beneath our feet. One of the more concerning aspects of supervolcanoes is how little we truly understand about their long-term behavior. Unlike traditional volcanoes, which erupt more frequently and provide more opportunities for study, supervolcanoes operate on timescales that extend far beyond human lifetimes. The data we have comes from geological evidence, traces of past eruptions preserved in rock layers, ice cores, and sediment samples. These records tell us that supervolcanic eruptions have reshaped the planet before and will do so again, but they don't tell us exactly when or how to stop it. Complicating matters further, the warning signs of a supervolcanic eruption don't always follow a predictable pattern. For instance, in the case of the Yellowstone caldera, there have been periods of intense seismic activity followed by decades of relative calm. The magma chamber itself is dynamic, shifting and expanding in ways that scientists are still working to fully grasp. Some argue that an eruption is likely centuries away, while others believe that the unpredictability of these systems means that an event could occur much sooner than we expect. Meanwhile, other potential supervolcanoes around the world, such as Campi Flegrei in Italy or Taupo in New Zealand, are showing their own signs of activity. Campi Flegrei, located near Naples, has experienced a surge in seismic activity over the last few years, prompting concerns that magma movement beneath the surface could be reaching a critical stage. A full-scale eruption here would be devastating for Europe, sending ash across the continent and severely disrupting global climate patterns. Governments and scientific institutions continue to discuss ways to mitigate the risks, but practical solutions remain elusive. Some proposals include large-scale geoengineering projects, like injecting water into magma chambers to cool them down or using deep drilling techniques to release pressure gradually. However, these interventions are still largely theoretical, and some experts worry that interfering with a supervolcano could have unintended consequences. In the face of these uncertainties, the only real option for now is preparation. Some countries have begun developing more comprehensive disaster response plans, focusing on food security, alternative energy sources, and emergency evacuation strategies. But for most of the world, the threat of a supervolcano remains a distant, abstract concern, one that doesn't seem urgent until it's too late. And that's what makes this such a dangerous scenario. Unlike hurricanes, earthquakes, or even asteroid impacts, a supervolcanic eruption isn't something that can be easily observed in advance. There will be no countdown, no precise warning system, no last-minute evacuation for millions of people. When it happens, it will happen fast, and the effects will be immediate and irreversible. The only question is whether humanity will be prepared, or caught completely off guard. As the years pass, the silent threat of supervolcanoes continues to loom over humanity. Their immense power, waiting just below the Earth's surface, remains an unpredictable force that we are still learning to understand. Despite decades of study, we have only scratched the surface of what truly triggers a supervolcano's eruption. The combination of factors, magma buildup, tectonic movements, seismic events, and underground shifts, is a complex puzzle that we are still piecing together. The potential for a supervolcano eruption to disrupt not just local areas but the entire planet cannot be understated. The volcanic winters caused by their eruptions would dramatically alter the global climate, triggering severe temperature drops, widespread crop failures, and economic collapse. What's more alarming is the reality that these eruptions are not isolated events in the distant past. Many experts believe that we are living in a time when the next eruption could occur at any moment. One of the critical questions scientists are grappling with is why these supervolcanoes erupt at all. Some hypothesize that it's a natural process, a release of built-up pressure from the Earth's core over time, but others suggest that human activity could be contributing to the destabilization of these underground systems. The mining of natural resources, deep drilling, and even climate change have the potential to interfere with the delicate balance that has kept these massive forces dormant for centuries. As the global population continues to grow and the strain on Earth's resources increases, the risks associated with supervolcanoes become even more pronounced. Should one of these colossal eruptions occur, the world would face unprecedented challenges in trying to survive. Even countries with the most advanced technological infrastructure may find themselves overwhelmed by the scale of devastation. And unlike many other natural disasters, there would be no way to evacuate in time or escape the fallout. In the absence of a clear answer on how to prevent an eruption, the focus must shift to preparedness and resilience. While governments and scientific bodies continue to study supervolcanoes and assess the risks, it's essential that we as a global community begin to think about how we can mitigate the effects of such a disaster. From creating global food security strategies to developing alternative energy systems that are less dependent on climate stability, every effort will be needed to prepare for a future that may very well be shaped by one of nature's most powerful forces. The possibility of a supervolcano eruption is no longer just a theoretical risk, it is a reality that we must confront. The next eruption could occur in our lifetime, or it may still be centuries away, but either way, it is a ticking time bomb beneath the Earth's crust, waiting to change life as we know it. Are we ready to face the consequences of this global threat, or will we find ourselves, once again, unprepared for nature's wrath? Despite our advanced technology and understanding of the world, supervolcanoes remain one of the greatest mysteries of Earth's geological processes. For centuries, humanity has grappled with understanding the intricate workings of our planet's internal forces. The eruption of a supervolcano would undoubtedly be a cataclysmic event, but the nuances of these events are still only partially understood. It is the hidden complexity within Earth's crust, those deep, vast chambers of magma, that continue to perplex even the most seasoned geologists. A key challenge is the timeline of these eruptions. Most volcanoes erupt relatively quickly, within a few days or weeks. Supervolcanoes, on the other hand, operate on entirely different timescales. Their eruptions can be preceded by years, decades, or even centuries of geological activity before a full-scale eruption occurs. This slow buildup is part of what makes them so dangerous. Unlike a traditional volcano, where the warning signs may be obvious and lead to relatively swift evacuations, the supervolcano's warning signals are subtle and can occur over the course of generations. And while we now know more about what may trigger a supervolcano eruption, we still cannot pinpoint precisely when it will happen. Seismic activity around supervolcanoes is one of the most telling signs of a potential eruption. It's not uncommon to detect swarms of small earthquakes, some too small to even be felt by humans, but collectively, these tremors can suggest that magma is moving beneath the surface. In the case of Yellowstone, for example, there have been periods of significant seismic activity over the years, with earthquakes occurring at an increasing rate. While this alone doesn't indicate an impending eruption, it does suggest that there is ongoing movement beneath the surface. These tremors, though small, are enough to give geologists a glimpse of the forces at play within the caldera. The size of the magma chamber beneath a supervolcano is another critical factor in its potential for eruption. Unlike regular volcanoes, where magma chambers are relatively shallow, the magma chamber beneath a supervolcano can extend miles deep into the earth. In the case of Yellowstone, the chamber is estimated to be around 30 miles long, 45 miles wide, and up to 10 miles deep. This vast chamber holds enough magma to cause an explosion of unimaginable scale. And the longer this magma remains trapped and pressurized, the greater the chances of a catastrophic release. For centuries, scientists have been fascinated by the unique behavior of supervolcanoes. Much of what we know comes from studying the remnants of past eruptions, which have left behind enormous calderas, or crater-like depressions, where the ground has collapsed following an eruption. These calderas, scattered across the globe, tell the story of supervolcanoes that have reshaped the landscape in the past. The Yellowstone caldera is one of the most well-known examples, but similar systems exist in other parts of the world, such as the Taupo volcanic zone in New Zealand and the Campi Flegrei caldera near Naples, Italy. Each of these systems presents unique challenges in terms of monitoring and forecasting. While there are some common signs across supervolcanoes, such as increasing seismic activity, ground deformation, and changes in geothermal activity, there are also distinct differences between each system. The Taupo caldera, for example, has shown signs of recent activity, including a small eruption in the 1950s, and scientists have been closely monitoring the region ever since. Likewise, the Campi Flegrei caldera has been the subject of extensive study due to its proximity to Naples, one of Italy's most populous cities. The threat of an eruption in such a densely populated area is especially concerning. While studying the remnants of past eruptions is useful, it presents its own set of challenges. These ancient eruptions occurred thousands, sometimes millions, of years ago, and while we have uncovered many clues about their size and impact, the exact conditions that led to their eruption remain largely a mystery. What causes a supervolcano to erupt after millennia of dormancy? What triggers the final release of pressure? These are questions that continue to baffle researchers, and without definitive answers, our ability to predict future eruptions remains limited. What we do know is that supervolcanoes, unlike regular volcanoes, have the potential to reshape the entire planet. A supervolcanic eruption is not just an isolated disaster, it's a global event that could impact every country on Earth. The ash that is ejected into the atmosphere can spread around the globe, blocking sunlight and cooling the planet. This cooling effect, known as a volcanic winter, would be devastating for agriculture, as crops would fail in the extreme cold. In addition, the ash and sulfur dioxide that would be released into the atmosphere could lead to acid rain, further damaging ecosystems and crops worldwide. The last major supervolcanic eruption occurred about 26,000 years ago in what is now the Toba caldera in Indonesia. This eruption is thought to have been one of the most powerful volcanic events in Earth's history, releasing enough ash and sulfur into the atmosphere to cause a dramatic cooling effect on the planet. This event, known as the Toba event, is believed to have caused a global climate shift, leading to a volcanic winter that may have lasted for several years. The cooling effects of the eruption may have triggered widespread crop failures, leading to famine and massive loss of life. Some researchers even speculate that the Toba eruption could have caused a significant bottleneck in human evolution, as the harsh environmental conditions would have reduced the population of early humans. The Toba event is often cited as a cautionary tale of what a supervolcanic eruption could do to modern civilization. Today, with a global population of over 8 billion people and a highly interconnected world, the effects of such an eruption would be far more devastating. The scale of disruption that would occur, from collapsing agricultural systems to energy shortages, transportation gridlock, and widespread civil unrest, would be beyond anything that human society has ever experienced. In addition to the immediate effects of the eruption, there would be long-term consequences that could last for years or even decades. The cooling of the planet would have a profound impact on ecosystems, causing widespread disruption in food chains. Many species of plants and animals are highly sensitive to temperature changes, and even small shifts in climate can have devastating effects on biodiversity. A volcanic winter could lead to the extinction of countless species, as they struggle to adapt to the rapidly changing conditions. The economic consequences of a supervolcano eruption would also be profound. Modern economies rely on complex systems of trade, agriculture, and energy production, all of which are dependent on stable environmental conditions. A sudden volcanic winter would disrupt these systems on a global scale, leading to widespread shortages of food, fuel, and other essential resources. Supply chains would be severed, and transportation networks would collapse under the weight of the disaster. Countries that rely on food imports would be particularly vulnerable, as global trade would grind to a halt. In this chaotic environment, nations would be forced to scramble for resources. Governments would need to implement emergency response strategies to ensure the survival of their populations. This would include stockpiling food, medical supplies, and energy resources, as well as developing plans for large-scale evacuation and relocation. But with so many people to care for and so few resources available, tensions would inevitably rise, and conflicts over access to food, water, and shelter could erupt between nations and within borders. Given the global impact of a supervolcanic eruption, it is critical that countries around the world begin to consider how to respond to such a disaster. While the likelihood of an eruption happening in the near future is still uncertain, the potential consequences are so dire that it warrants serious consideration and preparation. Some countries have already begun to develop contingency plans for such an event, including efforts to increase food security and build resilience to environmental shocks. However, these efforts are still in the early stages, and much more needs to be done to prepare for the worst-case scenario. One of the biggest challenges in preparing for a supervolcanic eruption is the unpredictability of the event. While scientists are making great strides in understanding the behavior of supervolcanoes, predicting when an eruption will occur is still nearly impossible. The forces at work beneath the Earth's surface are complex and dynamic, and there are many variables that can influence the timing and scale of an eruption. As a result, the best we can do is to continue monitoring these systems, gather more data, and develop plans to respond if and when the time comes. At the same time, we must also consider the ethical implications of such preparation. If an eruption were imminent, how should governments respond? Should they prioritize evacuation efforts, or focus on safeguarding critical infrastructure? Should they attempt to contain the damage by implementing geoengineering solutions, such as injecting aerosols into the atmosphere to block sunlight? These are difficult questions with no easy answers, and they highlight the complexities of preparing for a disaster of this magnitude. The unpredictability of supervolcanoes means that the world must remain vigilant, ready to act, but also prepared for the possibility that nothing can prevent the coming disaster. As our understanding of supervolcanoes continues to evolve, one thing is clear: the threat they pose is real, and we must not ignore it. These ancient, powerful systems have the potential to reshape the planet in ways we can hardly imagine. And while we cannot predict exactly when or where the next eruption will occur, we must remain aware of the risks and do everything in our power to prepare. Only then can we hope to weather the storm when the time comes. The immense power of supervolcanoes is not only seen in the destructive effects they have on the environment and human civilization, but also in the long-lasting scars they leave on Earth's geological structure. The eruptions of these massive systems can reshape entire landscapes, leaving behind vast calderas, some of which span hundreds of miles across. These calderas are a testament to the sheer magnitude of supervolcanic events, as the ground itself collapses in on itself after the explosive release of magma and gases. The effects on the Earth's surface are profound and irreversible. For example, the Yellowstone caldera, which spans an area of over 1,500 square miles, is one of the largest active volcanic systems on Earth. The last major eruption at Yellowstone occurred around 640,000 years ago, but even today, the caldera remains an active geothermal hotspot. The land surrounding the caldera is riddled with hot springs, geysers, and fumaroles, indications that magma is still present beneath the surface, heating the groundwater and causing it to rise to the surface as steam. This continued geothermal activity is one of the reasons scientists keep such close watch on the Yellowstone region. It's important to note that while the eruption of Yellowstone or any other supervolcano would be catastrophic, the actual timeline of these eruptions can vary greatly. Some researchers believe that Yellowstone's eruption may not happen for thousands of years, while others think it could occur much sooner. The fact remains that supervolcanoes are inherently unpredictable, and predicting when they will erupt, or even if they will erupt at all, remains a monumental challenge. What we do know, however, is that supervolcanoes can be triggered by a variety of factors. These systems can be influenced by tectonic activity, the movement of Earth's plates, and the shifting of magma beneath the surface. Sometimes, smaller volcanic events or earthquakes can signal that a larger eruption is on the horizon. It is also possible that a supervolcano could be triggered by an external event, such as the impact of an asteroid or comet. While this is a less likely scenario, it's still a possibility that scientists consider when assessing the risks posed by these geological systems. In many ways, supervolcanoes represent the ultimate natural disaster. They have the power to alter the course of human history, causing widespread devastation and even altering the climate on a global scale. Unlike more common natural disasters such as hurricanes, earthquakes, or floods, supervolcanoes have the potential to affect every person on Earth, regardless of where they live. Their sheer scale and unpredictability make them a unique threat to modern society. One of the most concerning aspects of supervolcanoes is their potential to trigger a domino effect of environmental and social challenges. The eruption itself would be catastrophic, but the aftermath could be just as damaging. The release of massive quantities of volcanic ash and gases into the atmosphere would lead to a significant cooling of the planet, triggering what is known as a volcanic winter. This phenomenon, in which the Earth's temperatures drop dramatically due to the blockage of sunlight, would have far-reaching consequences for ecosystems and human society. The cooling effects of a volcanic winter would be felt around the world, with temperatures dropping by several degrees Celsius, enough to disrupt the delicate balance of ecosystems. Agriculture would suffer immensely, as the shortened growing seasons and cooler temperatures would make it impossible to grow enough food to feed the global population. In the aftermath of the eruption, mass starvation and widespread food shortages could become a reality. This, in turn, could lead to global political instability, as countries fight for access to the dwindling resources available. Moreover, the ash released into the atmosphere would not only block sunlight but also contaminate air and water supplies, making the environment even more hostile. Acid rain, resulting from the interaction of sulfur dioxide and water vapor, could severely damage crops and infrastructure, further exacerbating the challenges faced by humanity in the wake of such a disaster. The long-term effects of these environmental changes could last for decades, making it difficult for societies to recover and rebuild. In addition to the environmental and social disruptions, the global economy would be severely impacted. Modern economies rely on stable weather patterns, reliable crop yields, and functioning supply chains. A sudden volcanic winter would disrupt all of these systems, causing widespread economic collapse. Global trade would grind to a halt, as shipping and transportation would become impossible in the face of destroyed infrastructure and extreme weather conditions. The collapse of agriculture and food production would further destabilize economies, leading to widespread poverty and social unrest. While the impact of a supervolcanic eruption is truly catastrophic, it is important to remember that the threat is not imminent. While scientists are closely monitoring potential supervolcanoes around the world, such as Yellowstone, Taupo, and Campi Flegrei, the chances of an eruption happening in the near future remain low. However, that does not mean we can afford to ignore the risk. Given the global consequences of such an event, it is crucial that we continue to study these systems, gather data, and develop contingency plans to mitigate the potential impact. One of the most important steps in preparing for a supervolcanic eruption is improving our understanding of these geological systems. While we have made great strides in monitoring seismic activity, ground deformation, and geothermal changes around supervolcanoes, we still have much to learn about the long-term behavior of these systems. Scientists are using a variety of tools and techniques to study the inner workings of supervolcanoes, including satellite imaging, seismic sensors, and geochemical analysis. These efforts help scientists track the movement of magma beneath the surface and identify potential warning signs that an eruption may be imminent. Additionally, advances in computer modeling and simulation are allowing scientists to better understand how supervolcanoes behave over time. By simulating the behavior of magma chambers and other geological processes, researchers can gain insight into the conditions that might lead to an eruption. While these models are still in the early stages, they hold promise for improving our ability to predict when and where a supervolcano may erupt. Another critical aspect of preparing for a supervolcanic eruption is developing global response strategies. While individual countries may have their own disaster response plans, a supervolcano's effects would be so widespread that no nation could deal with the crisis alone. Instead, the world would need to work together to coordinate efforts and share resources in the aftermath of an eruption. This could include organizing international relief efforts, establishing emergency food and water supplies, and ensuring that critical infrastructure, such as transportation and energy systems, remains functional in the face of widespread disruption. There is also the potential for technological innovations to play a role in mitigating the effects of a supervolcanic eruption. One idea that has been proposed is the use of geoengineering to counteract the cooling effects of volcanic ash. This could involve the injection of aerosols into the atmosphere to reflect sunlight and counteract the drop in temperatures caused by the eruption. However, such geoengineering solutions are highly controversial and largely untested on a large scale. They also carry significant risks, as altering the Earth's atmosphere in such a way could have unintended consequences that are impossible to predict. Another approach that has been suggested is the use of advanced farming techniques, such as vertical farming or hydroponics, to ensure that food production can continue even in the face of a volcanic winter. These techniques, which involve growing crops in controlled, indoor environments, could provide a way to produce food without relying on the traditional agricultural systems that would be devastated by the eruption. However, these methods are still in their infancy, and large-scale implementation would require significant investment and development. Ultimately, the best approach to mitigating the effects of a supervolcanic eruption is a combination of preparation, research, and international cooperation. By continuing to monitor the activity of supervolcanoes, improving our understanding of their behavior, and developing contingency plans to address the aftermath of an eruption, we can minimize the risks and ensure that humanity is better equipped to face this unprecedented natural disaster. While we cannot predict exactly when or where a supervolcano will erupt, we can work to ensure that we are as prepared as possible when the time comes. In the meantime, the threat of a supervolcano remains one of the most significant and least understood risks facing humanity today. Though it may seem like a distant and abstract concern, it is a threat that we cannot afford to ignore. The potential consequences of a supervolcanic eruption are simply too severe to overlook. By continuing to study these massive geological systems, working together on global response strategies, and exploring innovative ways to adapt to the challenges of a volcanic winter, we can ensure that humanity is ready to face whatever the Earth throws our way. As we continue to examine the potential fallout from a supervolcanic eruption, we must also consider the broader impact on biodiversity. The immediate effects of such an event, like the darkening of the skies and the significant drop in temperatures, would disrupt ecosystems across the globe. Plants and animals that are reliant on stable climates and growing seasons would find it increasingly difficult to survive. The volcanic winter could persist for years, causing cascading effects throughout the food chain. Agricultural systems would struggle to adapt to the new, colder environment. Crops that once thrived in certain regions would no longer be able to grow, and the global food supply would be drastically affected. Livestock farming, too, would face insurmountable challenges, as feed crops would fail, and colder temperatures would make it difficult to raise animals. In some cases, entire species of plants and animals could be driven to extinction, particularly those that are already vulnerable to changing environmental conditions. human survival would be deeply intertwined with our ability to protect the food chain. Without a reliable food source, communities would begin to struggle with the basics of survival. Even if food could be imported from other regions, the global transportation infrastructure would be severely disrupted. Roads, ports, and airports would be buried under volcanic ash, rendering them inaccessible. Communication systems could break down as power grids fail. While the initial eruption itself would cause immediate loss of life, the longer-term consequences could prove even more devastating. The resilience of human societies would be tested as never before. While some populations may be able to survive by relying on alternative food sources, such as fish, wild game, or alternative farming methods, the scale of the disaster would be too much for many nations to handle on their own. The reliance on global cooperation would become all the more apparent as countries struggled to find ways to mitigate the effects of the eruption. International humanitarian efforts would become a priority, as nations worked together to provide food, clean water, and medical aid to those affected by the eruption. However, these efforts would be complicated by the scarcity of resources. The collapse of agriculture would lead to food shortages across the world, and access to clean water could become a critical concern, as ash contamination would make rivers, lakes, and groundwater undrinkable. In addition to the physical challenges of survival, the psychological toll of such a disaster would be immense. Social systems could unravel as people fight for limited resources. Governments, struggling to maintain order in the face of widespread disaster, could become unstable, and civil unrest could spread. The psychological strain of living through such an event would weigh heavily on people, as they face the loss of loved ones, homes, and the very structures that once provided security. Social cohesion could disintegrate, giving rise to conflict and strife. The most vulnerable populations, those living in poverty or in areas already experiencing social instability, would bear the brunt of these challenges. Without access to emergency resources, healthcare, or support systems, these communities could face extreme hardship. Refugees fleeing affected regions might overwhelm neighboring areas, leading to further strain on already limited resources. While the effects of a supervolcanic eruption would be felt by all, the magnitude of the disaster could also highlight stark inequities across the world. The rich and powerful may be able to shield themselves somewhat from the worst effects, while the poor and disenfranchised are left to fend for themselves. This could lead to a further divide between different regions, as those with the means to survive may consolidate resources, leaving others to struggle. Governments and international organizations would need to work quickly to ensure that these disparities are addressed, but the magnitude of the disaster could make such efforts incredibly difficult. Despite the magnitude of the threat, it is crucial to acknowledge the resilience of humanity in the face of disaster. While the eruption of a supervolcano would undoubtedly change the world as we know it, the potential for recovery is not entirely beyond our reach. History has shown that human societies, though often tested by adversity, have an incredible capacity to adapt. After the eruption of Mount Tambora in 1815, for example, humanity endured widespread famine and social upheaval, yet eventually rebuilt. If we are to face the reality of a supervolcanic eruption, we must consider what steps can be taken to rebuild in the aftermath. One of the most important factors in recovery will be the ability to harness technology and innovation to adapt to new challenges. In a post-eruption world, efforts will need to focus on sustainable food production, renewable energy, and new methods of climate control to offset the global cooling effects. Furthermore, we will need to explore new ways of organizing societies to ensure that the most vulnerable populations are protected. In terms of agriculture, the use of alternative farming methods could play a significant role in the recovery process. Vertical farming, hydroponics, and other techniques that allow crops to be grown in controlled environments could provide a way to produce food without relying on traditional agricultural systems. These technologies, though not yet widely implemented, hold great potential for meeting the food needs of a post-eruption world. Similarly, advancements in renewable energy could help mitigate the energy crisis that would follow a supervolcanic eruption. With traditional power grids and infrastructure destroyed by ash and volcanic debris, alternative energy sources such as solar, wind, and geothermal power would become even more essential. The ability to harness these energy sources, even in the midst of a cooling planet, could ensure that critical services like hospitals, communication systems, and food production remain functional. Additionally, the development of new communication systems will be critical for coordinating relief efforts. As the eruption disrupts traditional infrastructure, satellite communication and other advanced technologies will be essential for ensuring that governments, relief organizations, and individuals can stay in contact and share vital information. With effective communication systems, efforts to distribute aid and organize evacuations could proceed more smoothly, potentially saving thousands of lives. While the physical and technological challenges of recovery would be immense, the psychological resilience of people could prove equally vital. Communities that can come together in the aftermath of disaster, pooling resources and supporting one another, would stand the best chance of recovery. The global community, despite the enormous strain, could rally around a common goal of survival and rebuilding. A renewed sense of cooperation and solidarity may emerge, as nations set aside differences to tackle the monumental challenge ahead. Yet, the road to recovery will be long, and the scars of the supervolcanic eruption will remain for generations. The Earth itself will bear the marks of this catastrophic event, with altered landscapes and ecosystems that may never fully return to their previous state. The human impact will be just as profound, with the memories of the disaster shaping the future of civilization. In the years following the eruption, humanity will likely reassess its relationship with the Earth. We will need to consider how we manage the planet's natural systems and how we can better prepare for the unpredictable forces of nature. In a post-supervolcanic world, the lessons learned from such a disaster could reshape everything from how we live to how we interact with the environment. In the aftermath of a supervolcanic eruption, societies would likely turn to science and technology not only to rebuild but to understand how to live more harmoniously with the planet's unpredictable nature. The eruption would act as a powerful reminder of the fragile balance between human civilization and the forces of nature. Scientists, engineers, and policymakers would be tasked with addressing the consequences of this disaster and finding ways to prevent similar events from catching the world off guard in the future. One avenue of research that would likely see significant investment is the study of volcanic activity and early warning systems. While the eruption of a supervolcano may still be difficult to predict with any certainty, advancements in technology could improve our ability to detect signs of impending disaster. Seismic sensors, ground deformation monitoring, and satellite imagery could be used to provide more detailed real-time data on volcanic systems, allowing for better predictions about when, where, and how a supervolcanic event might occur. In addition, international collaboration between governments and scientific institutions could lead to the creation of more robust global monitoring systems designed to provide earlier warnings and enhance emergency preparedness. One potential avenue of innovation in this regard could be the development of sophisticated AI-driven algorithms that analyze seismic data and other indicators of volcanic activity. These systems could potentially predict future eruptions with much greater precision, taking into account a wider range of variables than human analysts currently can. In addition, predictive modeling could help identify which regions are most at risk, allowing governments to prepare more effectively for the possibility of an eruption. Furthermore, studying the long-term environmental effects of supervolcanic eruptions could provide crucial insights into how we might adapt to a world that has been dramatically changed by such an event. Climate scientists and environmentalists would need to assess how cooling effects from volcanic ash and sulfur dioxide could alter ecosystems and weather patterns, and what steps humanity could take to mitigate the effects on agriculture, biodiversity, and human health. This knowledge could help guide future environmental policies and foster a more sustainable approach to resource management in an increasingly unpredictable world. While the scientific community would undoubtedly play a crucial role in preparing for future supervolcanic events, the political and social dimensions of recovery and preparedness would be just as important. Governments would need to reevaluate their disaster preparedness plans and create comprehensive strategies for responding to such large-scale catastrophes. International cooperation would become vital in addressing global food security, managing migration, and rebuilding economies in the wake of a supervolcanic eruption. In terms of food security, one of the most pressing concerns after a supervolcanic eruption would be the long-term disruption of global agricultural systems. As temperatures plummet, crops would fail, and entire regions would experience a collapse in food production. One potential solution to this issue could lie in the development of advanced food production technologies, such as lab-grown meat, vertical farming, and hydroponic systems. These methods could allow for the production of food in controlled environments, reducing reliance on traditional agricultural systems and offering a way to ensure a stable food supply even during periods of global cooling. Additionally, governments would likely invest in the creation of vast food reserves to provide for populations in the immediate aftermath of an eruption. These reserves would need to be carefully managed and distributed to ensure that food reaches the most vulnerable regions. The logistics of such an operation would be complicated by the widespread destruction of infrastructure, but global cooperation and resource sharing could make it possible to provide food aid to those in need. Water security would also be a critical concern. As volcanic ash blankets the landscape, it would contaminate rivers, lakes, and groundwater, making fresh water sources scarce. This would force governments and international organizations to explore innovative solutions for providing clean water to affected populations. Desalination plants, water purification technologies, and large-scale water collection systems could become essential for meeting the basic needs of survivors. The question of migration would also come to the forefront in the aftermath of a supervolcanic eruption. Large areas around the eruption site would become uninhabitable due to ash fall, seismic activity, and potential lava flows. Communities would be forced to flee their homes, seeking refuge in less affected areas. The movement of people on such a massive scale would put immense pressure on neighboring countries, which would need to provide shelter, food, and medical care to displaced populations. The global response to migration would need to be coordinated and compassionate, as countries work together to provide for those displaced by the disaster. However, migration could also lead to political tensions. Nations may struggle to balance the needs of their own citizens with the demands of refugees from supervolcanic zones. International agreements and treaties could be forged to address the humanitarian crisis and ensure that displaced people are given the resources and protection they need. But in a world already grappling with limited resources, the strain on international relations could intensify. In the face of such a global crisis, the role of social networks and local communities would become more important than ever. Small-scale community efforts to rebuild, share resources, and provide emotional support would help sustain populations as they struggle to survive. The emotional and psychological toll of a supervolcanic eruption would be immense, and communities would need to focus on mental health and recovery as they rebuild their lives. The importance of education and knowledge dissemination would also come to the forefront. Schools and universities could become critical hubs of knowledge, training the next generation of scientists, engineers, and emergency responders to deal with the challenges posed by such an event. Public education campaigns would need to focus on disaster preparedness, ensuring that communities are equipped with the knowledge they need to survive in a world that has been reshaped by a supervolcanic eruption. As we look to the future, the legacy of a supervolcanic eruption could be a turning point in human history. Just as past natural disasters have spurred advancements in medicine, technology, and infrastructure, so too could the eruption of a supervolcano prompt new innovations in disaster management, environmental sustainability, and global cooperation. While the immediate aftermath would be devastating, humanity's ability to adapt and rebuild would ultimately define the resilience of civilization. In the years following the eruption, we may look back at the event as a moment when humanity came together to face the greatest natural disaster in recorded history. The lessons learned during this period of global hardship would shape the way we approach future risks and threats, ensuring that we are better prepared for whatever challenges the Earth might throw our way in the future. As humanity rebuilds in the wake of a supervolcanic eruption, the emphasis on global cooperation and adaptation would continue to grow. The future of disaster preparedness and response would depend heavily on lessons learned from this catastrophe, and scientific innovation would be critical to mitigating future risks. There would be a shift in how we approach the planet, moving from a mindset of exploitation to one of stewardship and understanding. The sheer scope of a supervolcanic eruption would also force a reevaluation of how cities and infrastructure are designed. Earthquakes, volcanic eruptions, and other natural disasters often expose vulnerabilities in human-made structures, but the scale of devastation caused by a supervolcanic event would call for more resilient, adaptive strategies. Cities might be built with deeper foundations to withstand seismic activity and to account for the likelihood of volcanic fallout. New technologies in construction could focus on creating buildings that are not only stronger but also self-sufficient, with sustainable energy sources, water purification systems, and food production capabilities. Moreover, governments worldwide might begin to prioritize disaster-proof infrastructure, funding new research into materials that can withstand extreme heat, ash, and seismic forces. These innovations would not only help protect populations in volcanic zones but also in areas vulnerable to other natural disasters. The creation of self-sustaining cities, or disaster-proof urban areas, could become a standard of future city planning, ensuring that the human race is not only able to survive but thrive in the face of nature's fury. One of the most profound impacts of a supervolcanic eruption would likely be on the global economy. Industries across the world would be disrupted, with agricultural, manufacturing, and trade sectors experiencing catastrophic losses. As food shortages become widespread, the need for alternative food production systems would become increasingly urgent. Vertical farming, lab-grown meat, and hydroponic systems, as previously mentioned, could become the norm, providing not only food security but also solutions to the environmental degradation caused by traditional farming methods. These technologies could alleviate some of the pressure on ecosystems, offering a sustainable way to feed the growing global population while reducing the reliance on land-based agriculture. As the world shifts toward new methods of food production, economies will need to adapt by focusing on sustainable industries. Renewable energy sources such as solar, wind, and geothermal power would take on even greater importance, particularly in regions that are affected by volcanic ash or where traditional energy infrastructure has been destroyed. Solar power, for example, could become the primary source of energy for entire regions as traditional grids become less reliable. New technologies in energy storage could ensure that communities have access to electricity even during extended periods of cloud cover caused by volcanic ash. In addition to food and energy, water management systems would be critical in ensuring that populations have access to clean drinking water. Innovations in desalination, water recycling, and filtration technologies could become crucial in regions where fresh water sources are contaminated or depleted by volcanic activity. New ways of conserving and distributing water would be necessary to meet the needs of growing populations and to mitigate the strain on dwindling resources. The impact of the eruption on biodiversity would also require significant attention. As ecosystems are disrupted and habitats are destroyed by ash fall, temperature changes, and altered rainfall patterns, species of plants and animals would be pushed to the brink of extinction. Conservation efforts would be ramped up, with a focus on preserving genetic diversity in case future recovery efforts are needed. Some species may adapt to the changing climate, while others may struggle to survive, leading to shifts in ecosystems that could take centuries to stabilize. In addition to these practical concerns, the eruption of a supervolcano would also have a profound psychological and emotional impact on survivors. The trauma experienced by those who witnessed the destruction of their homes, communities, and livelihoods would be significant. Long-term mental health care would be needed on a global scale, with an emphasis on providing support for individuals suffering from anxiety, depression, and post-traumatic stress disorder. The importance of social cohesion and community support would be critical as people rebuild their lives and find ways to cope with the emotional scars left by such a cataclysmic event. Education systems would also play a vital role in the recovery process. Students who have lived through a supervolcanic eruption would need a curriculum that addresses the psychological, environmental, and economic challenges they face. These students would likely become the generation of innovators who, having witnessed the fragility of human civilization, would be motivated to find solutions to the problems exacerbated by the eruption. Schools and universities could become incubators of new ideas for sustainable living, disaster preparedness, and ecological restoration. By emphasizing resilience, adaptability, and a deeper connection to the Earth, the next generation would be better equipped to navigate a world that has been forever altered by the eruption. In the global community, rebuilding efforts would emphasize not only technological innovation and infrastructure but also a collective sense of responsibility for the future of the planet. As nations come together to share resources and rebuild, there would likely be a shift toward more cooperative models of governance and problem solving. National borders would become less important as the world faces a shared existential threat, and global cooperation would be essential in addressing the long-term consequences of the eruption. In some ways, a supervolcanic eruption could serve as a catalyst for a new age of environmental consciousness. The shared experience of surviving such a catastrophic event would likely spark a global movement towards sustainability, social responsibility, and a rethinking of how humans relate to the planet. With new technologies at our disposal, it may be possible to reverse some of the damage done by the eruption, but it will require a global commitment to preserving the Earth's ecosystems and ensuring that future generations can thrive in a rapidly changing world. While the immediate aftermath of a supervolcanic eruption would be devastating, it could also represent an opportunity for humanity to reconsider its relationship with nature, refocus its efforts on sustainable living, and build a more resilient and interconnected world. The lessons learned from the eruption would echo throughout history, reminding us of our vulnerability, but also of our ability to adapt and innovate in the face of seemingly insurmountable challenges. In the wake of such a catastrophe, one of the most pressing questions would be how to ensure that future generations are better prepared for similar natural events. Education on disaster preparedness would no longer be optional, but a core component of global curricula. Schools and universities across the world would incorporate disaster resilience and response strategies into their teaching, training students not only in the sciences and technologies necessary to understand these events but also in the psychology and sociology of survival and recovery. As the long-term consequences of a supervolcanic eruption unfold, humanity might also turn its focus to the rebuilding of ecosystems. With the ash and sulfur from the eruption spreading across the globe, the immediate aftermath would result in a massive die-off of plant and animal life. Reforestation, replanting native species, and restoring habitats would become critical goals. A combination of ecological restoration efforts, land reclamation, and biotechnologies could be used to bring life back to regions that have been ravaged by the volcanic ash and changed climates. Scientists may also explore the potential of geoengineering to help restore balance to the atmosphere. Proposals for using carbon capture and storage (CCS) technologies, as well as large-scale projects to remove sulfur dioxide from the atmosphere, could be deployed to speed up the recovery of the Earth's climate. However, such interventions would come with their own risks, as the Earth's natural systems are incredibly complex. Any attempt to fix the climate could lead to unforeseen consequences, making caution paramount. In this new world, humanity might also recognize the fragility of their existence and the interconnectedness of all life on Earth. Environmental stewardship would become a global priority, with governments and corporations working together to address issues like deforestation, overfishing, and pollution, which would only compound the damage caused by the eruption. A growing environmental consciousness could lead to the development of new policies designed to protect ecosystems and ensure that human progress does not come at the expense of the planet's health. In this future, technology would play a pivotal role in restoring both the environment and the economy. Artificial intelligence and automation could be employed to monitor volcanic activity, predict potential threats, and develop systems that can adapt quickly to changing conditions. For example, AI-driven predictive models could analyze seismic data in real time, allowing scientists to identify early warning signs of volcanic activity and make informed decisions about evacuations or other emergency responses. Additionally, drones and other unmanned aerial systems (UAS) could be used to gather data from regions affected by volcanic eruptions, providing a detailed picture of the enabling early detection of global-scale natural disasters before they occur. As society rebuilds, it is likely that the way people live and work would change significantly. Remote working and decentralized living arrangements could become the norm, driven by the need to be less reliant on vulnerable centralized infrastructure. Communities might embrace more localized economies, where goods and services are produced and consumed within a closer geographic area. The lessons learned from the eruption would reinforce the need for resilience, adaptability, and resourcefulness. In the face of long-term global change, psychological resilience would be just as critical as physical infrastructure. The collective trauma of experiencing and surviving such a cataclysmic event would take a toll on the mental health of millions. Survivors would need access to trauma-informed care, counseling, and social support networks to help them cope with grief, loss, and the emotional scars of witnessing the destruction of their homes and lives. The healing process would take decades, and mental health care could become an essential part of the recovery process. Communities and societies worldwide would also need to grapple with the moral and ethical challenges posed by such an event. As resources become scarce, questions of equity and justice would arise. Who gets access to food, water, and shelter in the aftermath of a supervolcanic eruption? How do we ensure that the most vulnerable populations are protected? These questions would likely dominate political and social discourse, as the world strives to balance the needs of individuals with the needs of society as a whole. Additionally, the potential for political instability would rise as nations struggle to provide for their populations in the aftermath of the eruption. Global cooperation might be tested as nations prioritize their own survival over international agreements. The geopolitical landscape could shift dramatically, with new power dynamics emerging as countries with more resilient infrastructure and resources take on leading roles in recovery efforts. At the same time, tensions could rise as nations compete for the dwindling resources necessary to sustain life in a changed world. However, despite the challenges, a supervolcanic eruption could also foster a renewed sense of unity. The sheer scale of the disaster would require unprecedented levels of collaboration and solidarity, as nations put aside their differences to focus on survival and recovery. Global organizations like the United Nations, World Health Organization, and others could play crucial roles in coordinating relief efforts, providing aid to affected regions, and ensuring that resources are distributed equitably. Ultimately, a supervolcanic eruption would be a defining moment for humanity, a test of our resilience, ingenuity, and capacity for empathy. It would serve as a stark reminder that, while we may have conquered much of the Earth, nature is still a powerful and unpredictable force. The event would not only reshape our planet physically, but also reshape our attitudes, our values, and our sense of what it means to be human. The recovery process would not be quick, and the scars left by the eruption would remain for generations to come. But from the ashes of destruction, humanity would rise once again, stronger, wiser, and more determined to ensure that the Earth's future is one that we can face with hope and resolve. As the years pass and humanity begins to emerge from the ashes of a supervolcanic eruption, one of the most profound changes would likely be in the way we view our relationship with the Earth. The eruption would serve as a harsh reminder of the fragility of human civilization in the face of nature's power. The idea that we can control or tame the natural world would be seriously challenged, and many would start to reconsider our approach to environmental stewardship and sustainability. In the wake of such an event, society could experience a paradigm shift in how it views progress and development. The pursuit of endless economic growth and industrial expansion, which has long been a hallmark of modern civilization, might take a backseat to a new focus on resilience, adaptability, and harmony with nature. This would be a world in which humanity seeks to learn from the mistakes of the past and strives to create a more sustainable and balanced relationship with the planet. The scars left by the supervolcanic eruption, both physical and emotional, would serve as a catalyst for innovation and technological advancement. While the immediate aftermath would be marked by survival and recovery, long-term efforts would be directed toward building a more resilient future. Research into new, sustainable technologies would flourish, and the global push to transition to renewable energy sources would become more urgent than ever. The eruption would underscore the need for humanity to reduce its dependence on fossil fuels and to embrace cleaner, more sustainable forms of energy. Solar power, wind energy, and geothermal energy could take center stage in the rebuilding of society. With the eruption dramatically altering the climate, it is likely that new methods of energy production, a significant shift could occur in how humanity approaches urban planning and development. Cities, which have historically been built with a focus on convenience and economic growth, may be redesigned with resilience in mind. Buildings could be constructed with natural disasters in mind, using materials and designs that minimize damage in the event of earthquakes, volcanic eruptions, or other catastrophic events. Urban areas might adopt decentralized systems of energy, water, and food production, allowing them to function independently of larger national or global systems in times of crisis. Education would also change, with a focus on equipping future generations with the skills needed to survive and thrive in a world that has been forever altered. Critical thinking, adaptability, and problem-solving would become core components of education systems worldwide. Students would be taught not only the scientific principles behind natural disasters like supervolcanoes, but also the practical skills needed to live sustainably, adapt to changing environmental conditions, and respond effectively in the aftermath of such events. Global cooperation and governance would likely see a transformation as well. The eruption of a supervolcano could bring nations together in ways that previously seemed impossible. The scale of the disaster would require coordinated global efforts, and international institutions like the United Nations could become more robust and better equipped to address transnational crises. A global approach to disaster preparedness, climate change mitigation, and resource management might emerge, leading to a more unified world where cooperation is prioritized over competition. The world would also need to confront the psychological impacts of a supervolcanic eruption. Beyond the immediate physical destruction, the event would leave deep emotional scars on survivors. Entire communities would lose their homes, their families, and their way of life, and the trauma of such a catastrophe could ripple through generations. Mental health care would become a cornerstone of recovery efforts, and societies would need to provide support for those dealing with grief, loss, and the profound psychological effects of living through such a global disaster. Social structures could shift as well, with a renewed focus on community and mutual aid. In the aftermath of a supervolcanic eruption, survival would depend on people working together, sharing resources, and supporting one another. The traditional reliance on centralized governments and large corporations could diminish as more local, grassroots networks take on a central role in ensuring the well-being of their communities. A spirit of solidarity and collective action would likely emerge as the dominant response to the challenges posed by the eruption. In the face of this new world, humanity might look to the stars for answers. Space exploration and colonization could become more urgent as the Earth's future becomes increasingly uncertain. The desire to establish human colonies on other planets or moons could be driven by a need for survival, a way to ensure the continued existence of the human species in the event that Earth becomes uninhabitable due to the effects of a supervolcanic eruption or other global catastrophes. The dream of exploring and colonizing space, once the stuff of science fiction, could become a real and achievable goal on our planet, and how we can prepare for them. As humanity adapts to the challenges posed by a supervolcanic eruption, the fundamental question of what it means to be human may also be re-examined. The eruption would force us to confront our own vulnerability and mortality, challenging our perceptions of control, progress, and the future. The resilience of the human spirit would be tested, but the drive to survive, rebuild, and thrive would ultimately define the legacy of this catastrophe. In the end, a supervolcanic eruption would be a defining moment in human history, one that forces us to reconsider our place on this planet and our responsibility to future generations. It would push us to become more aware of the fragility of life, more connected to each other and the environment, and more committed to building a future that is sustainable, resilient, and capable of facing whatever challenges the Earth has in store. As we consider the long-term consequences of a supervolcanic eruption, it becomes clear that the very nature of these events is what sets them apart from more conventional natural disasters. Unlike the more frequent and predictable eruptions of standard volcanoes, supervolcanic eruptions operate on a timeline that spans thousands of years, making them an unpredictable and difficult threat to manage. In fact, the very unpredictability of supervolcanoes is one of the most frightening aspects of their existence. The scale of a supervolcanic eruption is so immense that it can fundamentally change the Earth's surface and atmosphere. The eruption itself could take the form of an explosive release of energy, followed by the collapse of the caldera, a massive crater formed by the collapse of the ground above the emptied magma chamber. Such an event would release millions of tons of ash, gas, and volcanic material into the atmosphere, which would have catastrophic effects on the global climate. One of the most immediate dangers is the ash cloud. A supervolcanic eruption would send billions of tons of ash high into the atmosphere, where it could remain suspended for months or even years. The fine particles of ash would block out the sun, causing temperatures to plummet across the globe, a phenomenon known as volcanic winter. This drastic cooling would disrupt agriculture, shorten growing seasons, and lead to widespread crop failures. With the global food supply strained, famines could spread quickly, leading to mass starvation in affected regions. But the impacts of a supervolcanic eruption would not be limited to just a few years. The eruption of a supervolcano would release enormous amounts of sulfur dioxide into the stratosphere, forming sulfuric acid aerosols that would further contribute to the cooling effect by reflecting sunlight away from Earth. This global cooling could last for decades or even centuries, with profound effects on ecosystems and human societies. While the immediate threat of an eruption may seem distant, scientists caution that we are living in a period of heightened risk. The geological activity beneath supervolcanoes such as Yellowstone, Campi Flegrei, and Taupo continues to be monitored closely. Small earthquakes, changes in gas emissions, and ground deformation are all signals that can suggest increasing pressure beneath the surface. However, these signs don't always follow a predictable pattern, and it is difficult to determine whether they represent the early stages of a supervolcanic eruption or if the system is simply settling into a new state of equilibrium. For example, in the case of Yellowstone, researchers have observed a steady increase in geothermal activity over the years, with areas of land within the park slowly rising due to the accumulation of magma beneath the surface. While emergency plans are in place for more common natural disasters like earthquakes or hurricanes, a supervolcanic eruption is in a class of its own, one that presents unique challenges to both scientists and governments. Many of the current efforts to study supervolcanoes focus on understanding their long-term behavior, rather than trying to predict the exact moment of eruption. Scientists use a combination of geological surveys, seismic monitoring, and satellite imagery to gather data about the size and activity of magma chambers beneath supervolcanoes. They also study the history of past eruptions to better understand how these systems behave over time. For example, the eruption of the Yellowstone supervolcano approximately 640,000 years ago was one of the most powerful volcanic events in Earth's history. The eruption was so massive that it created a caldera nearly 30 miles wide. However, scientists do not know exactly what triggered this eruption, or how long the magma chamber took to reach the pressure necessary for such an explosion. This uncertainty has led some to question whether our current understanding of supervolcanoes is sufficient to prepare for their potential eruption. One of the most critical aspects of monitoring supervolcanoes is understanding the behavior of the magma chambers beneath them. These chambers can take thousands of years to fill, and their expansion is often slow and subtle. However, when the pressure within the chamber reaches a critical threshold, the eruption can occur suddenly and with devastating force. Scientists are still working to determine the specific conditions that would cause a supervolcano to erupt, as even small fluctuations in pressure can lead to an explosion of catastrophic proportions. In the meantime, researchers are exploring several ideas for mitigating the risks posed by supervolcanoes. One such idea involves drilling into the magma chamber to release pressure gradually. The idea is that by relieving some of the pressure in a controlled manner, the likelihood of a catastrophic eruption could be reduced. However, this approach is fraught with risks. Drilling into the magma chamber could inadvertently trigger an eruption, as the release of pressure could destabilize the system. Despite this, some researchers continue to study this method, hoping to find a way to safely release pressure without causing an eruption. Another proposed solution involves geoengineering, specifically, the use of aerosols to artificially reflect sunlight and counteract the cooling effects of a volcanic winter. This could help mitigate the temperature drop caused by the ash cloud and sulfur dioxide released into the atmosphere. While this approach could help to alleviate some of the consequences of a supervolcanic eruption, it is still highly experimental and untested on a global scale. In addition to these potential solutions, some scientists are calling for more comprehensive global preparedness plans. These plans would focus on strengthening the resilience of infrastructure, ensuring that food production and supply chains are better equipped to handle large-scale disruptions. Emergency response strategies would also need to be updated to account for the unique nature of a supervolcanic eruption, with a focus on international cooperation and resource sharing. The concept of supervolcanoes and their destructive potential is often dismissed as a distant, unlikely event. After all, these types of eruptions are so rare that it seems almost impossible to imagine one happening in the near future. Yet, the terrifying reality is that the Earth's history is littered with evidence of catastrophic volcanic events that reshaped the planet. In fact, many of the landforms we see today, including mountain ranges and expansive plains, are the result of ancient supervolcanic eruptions. The most famous example of this is the Yellowstone caldera, but there are others scattered across the globe, each with the potential to erupt in a manner far more devastating than any eruption we've witnessed in recorded history. The enormity of the threat posed by supervolcanoes is not just about their explosive power, it's about the aftermath and the cascading consequences for life on Earth. We've seen how eruptions, even relatively small ones in comparison, have affected ecosystems. In 1815, the eruption of Mount Tambora in Indonesia caused what was known as the year without a summer. Temperatures dropped globally, and crops failed in North America, Europe, and Asia. The global climate was altered for years, resulting in widespread food shortages, famine, and significant disruptions to societies. This event, though catastrophic, was small in comparison to the power of a supervolcano, which could trigger a far more devastating cooling period, lasting decades or even centuries. Beyond just climate effects, the consequences of a supervolcanic eruption would ripple through every aspect of life on Earth. The initial blast and subsequent release of ash and gas would obliterate nearby regions, but the true scale of the disaster would extend far beyond the immediate impact zone. As the ash cloud spreads across the planet, it would cover vast stretches of land, making agriculture almost impossible. Major rivers could be blocked with volcanic debris, causing water shortages. Air travel would be grounded for months, as ash clouds would make flying hazardous. These disruptions wouldn't just affect the affected regions. The global economy would be severely impacted by the eruption. A sudden collapse in agriculture, combined with disruptions in manufacturing and global trade, would likely lead to a severe economic recession. In the worst-case scenario, the eruption could cause a global depression as nations struggle to maintain control over resources and manage the outflow of people from affected areas. Refugees would flood borders, causing potential conflict as governments scramble to accommodate large populations in need of food, shelter, and medical care. What makes this scenario so difficult to prepare for is the sheer unpredictability of it all. Unlike a hurricane or an earthquake, a supervolcanic eruption doesn't give much warning. Earthquakes and volcanic tremors that precede eruptions may occur, but the indicators are often subtle and hard to interpret. In many cases, these seismic events could be happening over the course of decades or even centuries before a full-scale eruption occurs. Given the global implications of a supervolcanic eruption, waiting for a set of warning signs before acting could already be too late. Given the profound global consequences, the scientific community has called for a concerted effort to improve our understanding of supervolcanoes, their activity, and the potential for eruption. One significant challenge is the difficulty in studying such massive, deep-seated systems. The magma chambers beneath supervolcanoes are often located miles beneath the Earth's surface, and accessing them is a monumental task. Even the most advanced geological techniques, such as seismic tomography, can only offer a partial picture of the behavior of these underground systems. Moreover, supervolcanoes are not static systems. They evolve over time, shifting in their behavior as magma accumulates, cools, and moves beneath the surface. Monitoring for subtle changes in seismic activity, gas emissions, and ground deformation is crucial to identifying any early signs of trouble. But even with the most advanced technology, predicting the exact moment of eruption remains impossible. While much attention is focused on supervolcanoes like Yellowstone and Campi Flegrei, scientists are also studying other, lesser-known supervolcanic sites. Taupo in New Zealand, for instance, has a history of enormous eruptions, with the last major event occurring around 26,500 years ago. Though it has been quiet for centuries, seismic activity in the region has increased in recent years, raising concerns that the magma chamber beneath Taupo could be building toward another massive eruption. The eruption of Taupo, if it were to occur today, would likely cause widespread devastation across the Pacific region, sending ash clouds as far as Australia and disrupting global weather patterns. Similarly, the volcanic system beneath the Icelandic island of Bardarbunga is another site of increasing interest. In recent years, the region has seen a significant increase in seismic activity, prompting researchers to monitor the area closely. While the chances of an eruption similar to Yellowstone's are low, the risk posed by Bardarbunga and similar supervolcanic systems cannot be discounted. Many of these supervolcanoes are dormant, but they are not dead. Given their history of massive eruptions, they are still active and could erupt again at any time. One thing is clear: supervolcanoes are not relics of Earth's past, but active threats that require continuous monitoring and study. In addition to basic research, a global effort to prepare for a potential supervolcanic eruption is needed. This includes more robust disaster response planning, international cooperation on resource sharing, and the development of technology that can help mitigate the impact of such an event. The only certainty is that, when it comes to supervolcanoes, we cannot afford to be caught off guard. Yet, despite the evidence of imminent risks, global preparedness remains woefully inadequate. Governments around the world have yet to implement comprehensive strategies for coping with a supervolcanic eruption. While some countries have been proactive in preparing for other natural disasters, such as earthquakes, tsunamis, and hurricanes, there remains a significant gap in planning for supervolcanic events. Many nations have yet to seriously consider the magnitude of the threat posed by these underground giants, and the lack of a global response strategy makes the threat even more ominous. In the absence of official preparedness plans, many researchers and scientists continue to explore ways to mitigate the impact of supervolcanoes. Some ideas include studying the possibility of artificially stimulating volcanic activity to release pressure in a controlled manner, while others are considering geoengineering techniques, such as deploying aerosols into the stratosphere to counteract the cooling effects of volcanic ash. While these ideas remain speculative and controversial, they highlight the need for urgent action. Another area of research is in the realm of sustainable agriculture. If a supervolcano were to erupt, the collapse of global food systems would be one of the most immediate threats. Researchers are exploring ways to produce food in controlled, closed environments, such as underground farming or hydroponics, to ensure a stable food supply in the event of widespread crop failure. The development of alternative food sources, including lab-grown meat and synthetic foods, could help to alleviate some of the pressure on global food production in the aftermath of an eruption. In addition to food security, energy production would also be severely impacted by a supervolcanic eruption. Solar and wind energy systems would be ineffective in a world where the sun's rays are blocked by volcanic ash, and fossil fuel production could be disrupted by the collapse of transportation and trade networks. preparing for this level of disruption would require a transition to more resilient and decentralized forms of energy generation, such as nuclear or geothermal energy, which are less vulnerable to climate changes and disruptions to global trade. Even though major supervolcanic events are rare, the data we gather from smaller eruptions can offer clues about the underlying mechanisms that drive these massive geological forces. For instance, eruptions like Mount St. Helens in 1980 or the eruption of Mount Pinatubo in 1991, while significantly smaller in scale, have provided valuable insights into how volcanic pressure builds and the early warning signs that can be observed. In the case of Mount St. Helens, the eruption was preceded by an unusual series of earthquakes and steam explosions. Seismic activity in the region increased, and for weeks, there were visible signs of bulging in the ground as magma moved beneath the surface. Though scientists were able to predict an eruption was imminent, the scale of the eruption itself was still far greater than anyone anticipated. The resulting blast left behind a massive crater and reshaped the surrounding landscape. By studying eruptions like St. Helens and Pinatubo, scientists have been able to refine their models of volcanic behavior, identifying patterns that may help predict when a supervolcano is nearing a critical point. However, predicting these events remains difficult because of the complex interplay of geological forces at work beneath the surface. One of the primary challenges in understanding supervolcanoes is their size and scale. These systems are often spread over vast regions, with magma chambers that can span hundreds of miles. At Yellowstone, for example, the magma reservoir stretches across an area approximately 30 miles wide, making it one of the largest active volcanic systems in the world. The sheer magnitude of these systems means that the buildup of pressure can occur over much longer periods of time compared to smaller volcanoes, which means warning signs may not always be as apparent until it's too late. Scientists are working on better ways to monitor these massive systems. One method gaining traction is the use of satellite imaging and geodetic techniques to detect subtle shifts in the landscape. By using radar and laser measurements, scientists can track even minor changes in elevation, allowing them to monitor the deformation of the Earth's crust caused by the movement of magma. This can provide early indications that a supervolcano is becoming more active. At Yellowstone, for example, there have been instances where parts of the park have lifted several inches over just a few months, signaling the movement of molten rock beneath the surface. In addition to monitoring ground deformation, researchers are also studying the composition of gases released by supervolcanoes. Magmatic gases like sulfur dioxide and carbon dioxide are often released in greater quantities as magma rises toward the surface. By tracking these gases, scientists can get a sense of how much pressure is building in a magma chamber, and whether there is an increased likelihood of an eruption. However, gas emissions can also fluctuate without necessarily indicating an imminent eruption, which adds to the complexity of prediction. Another key factor in understanding the threat posed by supervolcanoes is the behavior of the Earth's tectonic plates. Supervolcanoes are typically located at the boundaries of tectonic plates or in areas where hot spots of molten material rise from deep within the mantle. The interaction of these plates, whether through subduction or plate movements, plays a significant role in determining the intensity and frequency of volcanic activity. In some cases, the movement of tectonic plates may provide clues that an eruption is more likely. For example, as plates shift and interact, they can cause the formation of faults and fractures that allow magma to rise more easily to the surface. Understanding these processes is crucial in identifying areas of heightened risk and predicting the likelihood of future eruptions. A key area of focus for researchers studying supervolcanoes is the concept of volcanic tipping points. These tipping points refer to thresholds that, once crossed, could trigger a catastrophic eruption. The problem is that these tipping points are often extremely difficult to identify in advance. Some researchers argue that certain warning signs, such as a significant increase in seismic activity or a dramatic rise in the amount of gas emissions, could signal that a supervolcano is approaching a critical state. Others believe that supervolcanoes are inherently unpredictable, and that the eruption of one could be triggered by a combination of factors, such as a sudden shift in tectonic activity or the collapse of part of the magma chamber. The question remains, how do we prepare for an event that might be centuries, or even millennia, away? The unpredictability of supervolcanoes makes them difficult to model, and scientists can only speculate about how and when a supervolcanic eruption might occur. Some argue that we should focus on improving our understanding of the geological processes that govern these events, while others advocate for the development of new technologies to better monitor and predict the activity of supervolcanoes. Meanwhile, the potential consequences of a supervolcano eruption continue to loom large. Even though the eruption itself would be catastrophic, the long-term environmental effects are just as concerning. After the initial blast, a supervolcano would release massive quantities of ash and gases into the atmosphere. This material would not only darken the skies, blocking out sunlight for months or even years, but it could also drastically alter the chemical composition of the atmosphere. For example, sulfur dioxide released into the stratosphere would combine with water vapor to form sulfuric acid aerosols, which would reflect sunlight and cool the planet's surface. This process, known as global dimming, could lower global temperatures by several degrees Celsius, plunging the planet into a period of extreme cold. The global cooling effect could disrupt agricultural systems worldwide, leading to crop failures, food shortages, and widespread famine. In addition to temperature changes, volcanic ash would have a devastating impact on ecosystems. Ash falls would bury forests, rivers, and wildlife habitats, disrupting entire ecosystems. This ash would also contaminate water supplies, making clean drinking water scarce for millions of people. The accumulation of ash would also impact human infrastructure, damaging buildings, power lines, and transportation networks. As temperatures drop and sunlight is blocked by the ash cloud, plants would struggle to photosynthesize, leading to a collapse in the food chain. Herbivores would find it increasingly difficult to find sustenance, and carnivores would follow suit. Even species that survived the initial eruption would face an uncertain future as the planet's climate shifts dramatically. The long-term impact on biodiversity could be catastrophic, leading to mass extinctions. The consequences of a supervolcanic eruption wouldn't be limited to just environmental devastation. The societal impact would be profound. Governments would struggle to respond to the chaos, and millions of people would be forced to flee affected regions. Refugees would flood neighboring countries, further straining resources and potentially leading to conflict. The loss of life would be staggering, and the world would likely face a period of severe economic and social instability. The question of how to respond to such an event is still largely unanswered. While some have proposed geoengineering solutions, such as injecting aerosols into the stratosphere to counteract the cooling effects of volcanic ash, these ideas remain speculative and untested on a large scale. Others have suggested that we focus on improving our disaster response infrastructure, including stockpiling food, water, and medical supplies, and developing alternative energy sources to ensure that societies can continue functioning in the aftermath of an eruption. The bottom line is that the threat posed by supervolcanoes is very real, and it's something that humanity cannot afford to ignore. The magnitude of these events is so vast that it's difficult to fathom the consequences, but it's essential that we continue to study these natural phenomena in order to understand their behavior and prepare for the worst-case scenario. One of the major challenges is that supervolcanoes don't always behave according to the patterns we expect based on traditional volcanic systems. For example, we might expect a buildup of pressure to manifest through an increase in seismic activity, but supervolcanoes can be silent for long periods, even when magma is moving beneath the surface. Conversely, increased seismic activity may not always signal an impending eruption. Rather, it could simply indicate the normal movements of magma as it adjusts within the reservoir. The Yellowstone caldera, for instance, has experienced periods of intense seismic activity, yet there is no definitive way to know if these events are precursors to a major eruption. Scientists have observed episodes of ground deformation at Yellowstone, some of which have been substantial. Entire sections of the ground have risen by several inches or even feet, yet these changes don't always correlate with eruptions. This creates a significant challenge for scientists trying to predict when an eruption might occur and how to prepare for it. They are forced to work with probabilities and patterns, but the nature of these events remains enigmatic. Despite the unpredictable nature of supervolcanoes, several key patterns have emerged in the data, offering valuable insights into their potential behavior. One such pattern is the cyclical nature of volcanic activity. Evidence from the past suggests that supervolcanoes go through periods of dormancy, followed by phases of increased activity. These cycles can span thousands of years, and while they don't necessarily guarantee that an eruption is imminent, they do suggest that these massive volcanic systems are far from static. The eruption of the Toba supervolcano in Indonesia, which occurred around 74,000 years ago, is a prime example of the kind of catastrophic event that could occur again. The eruption released an enormous amount of ash and gases into the atmosphere, leading to a dramatic global cooling event known as a volcanic winter. While it's unclear exactly what triggered the eruption, studies of the Toba eruption and its aftermath have provided a crucial window into the potential global consequences of a supervolcano eruption. It is believed that this eruption may have caused a significant population bottleneck, with the human population dipping to dangerously low numbers in the aftermath. Looking at the geological history of supervolcanoes, researchers have found that these events often have profound, long-lasting effects on the planet's ecosystems and climate. A supervolcano eruption would not only alter the global climate for years or even decades, but it could fundamentally change the way ecosystems function. Even regions that survived the initial eruption would face dramatic shifts in their environments, from altered weather patterns to a massive disruption of food chains. As we consider the possibility of another eruption, it's crucial to remember that we are dealing with a global event, not just a regional disaster. A supervolcano doesn't just affect the area directly surrounding the eruption, it has the potential to change the entire planet. Ash clouds would spread across continents, and even regions far from the eruption site would experience significant changes in weather and climate. In the case of Yellowstone, which is located in the heart of the United States, the effects of an eruption would reach far beyond the American continent. The disruption of global agricultural systems would likely be one of the most devastating consequences. Even a relatively small decrease in global temperatures could lead to widespread crop failures, especially in regions that rely on predictable growing seasons. The cooling effects of volcanic ash would shorten growing periods, and the loss of sunlight would severely impact photosynthesis. As food production dwindles, so too would access to clean water and other essential resources. Given the scale of the potential destruction, it's clear that a supervolcanic eruption could lead to a global humanitarian crisis. The sudden collapse of agricultural systems, combined with the massive loss of life and disruption of infrastructure, would result in widespread famine, poverty, and societal breakdown. Entire regions would be uninhabitable, forcing people to flee from their homes and seek refuge elsewhere. This mass migration would further strain already scarce resources and could lead to geopolitical tensions, as countries scramble to secure what limited food and supplies are available. The long-term effects of a supervolcanic eruption would also extend to the environment. While the immediate aftermath would see massive devastation, the ecological recovery process would take centuries, if not longer. Entire ecosystems would need to rebuild from the ground up, and many species that are unable to adapt to the changing conditions would face extinction. It's likely that human civilization, as we know it, would undergo a profound transformation, with new ways of living emerging out of the ashes of the old world. In addition to the immediate global consequences of a supervolcano eruption, there are also concerns about the indirect effects on human health. The ash and gases released into the atmosphere would not only impact global temperatures, but they could also have direct health effects on humans. Ash inhalation is dangerous, causing respiratory issues and even death in severe cases. Those living close to the eruption would face the immediate danger of being buried by ash falls, but even those at greater distances could suffer from the long-term health effects of ash and gas exposure. As we explore potential mitigation strategies, one thing becomes clear: the best course of action is to prepare for the worst. Although it's unlikely that we can prevent a supervolcano eruption from occurring, we can take steps to minimize the impact it would have on society and the planet. Some researchers advocate for the development of early warning systems that would be able to detect signs of impending volcanic activity, giving people more time to evacuate and prepare. However, this remains a difficult task, as many supervolcanoes operate on timelines far longer than human lifespans, and predicting the exact moment when magma will breach the surface is still out of our reach. Geoengineering has also been proposed as a possible solution. Some have suggested that we could mitigate the effects of a supervolcanic eruption by releasing aerosols into the atmosphere to reflect sunlight and counteract the cooling effects of volcanic ash. However, these geoengineering solutions are still largely theoretical and untested, and there are many uncertainties about their effectiveness and potential unintended consequences. More practical measures may involve strengthening global food security and establishing backup plans for agricultural production. This could include stockpiling food and water, developing alternative agricultural techniques, such as vertical farming or hydroponics, and investing in technologies that could help provide food in the event of crop failures. Another key component of preparedness would be to build resilient infrastructure that can withstand. Supervolcanoes present a threat unlike any other, and while we may not be able to predict when or where the next eruption will occur, we can at least prepare ourselves to minimize the devastation. By continuing to study these massive volcanic systems and developing strategies to protect our societies, we may be able to weather the storm should the worst come to pass. In response to these immense challenges, some countries have begun developing disaster preparedness strategies, but the scale of what's needed remains overwhelming. These plans aren't just about emergency evacuation or building shelters. They need to be comprehensive, addressing food security, water purification, energy resilience, and long-term climate stabilization. Yet despite the potential for a supervolcano eruption to disrupt life as we know it, many nations remain unprepared, or at best, underprepared. Why is this the case? One reason is the nature of supervolcanoes themselves. These systems operate on time scales that far exceed human lifetimes. The data we gather often points to subtle shifts in seismic activity, ground deformation, and gas emissions, but these are not always reliable indicators of an impending eruption. In fact, scientists have observed periods of heightened activity followed by decades of relative calm, which complicates efforts to predict when or if an eruption might occur. But there's also the issue of funding. Supervolcano monitoring is expensive, and in many cases, governments prioritize immediate and more tangible threats. Natural disasters like earthquakes and hurricanes are part of the everyday conversation in disaster preparedness, while supervolcanoes are often seen as more of a distant possibility, one that doesn't warrant the same level of attention or resources. However, the potential fallout from such an eruption could dwarf the effects of these more immediate concerns. When an eruption does occur, it could overwhelm all of the other systems that society depends on, rendering traditional disaster response strategies ineffective. At this stage, monitoring efforts are critical, and researchers continue to examine supervolcanic systems using advanced technology, such as satellite imaging and remote sensing tools, to track any potential signs of activity. However, these methods are not foolproof, and there remains no way to predict with certainty when or if a supervolcano will erupt. In many ways, it's a waiting game, with scientists piecing together data from various sources to identify patterns that might indicate an impending eruption. One thing that has become clear, though, is the need for international collaboration. The risks posed by supervolcanoes are global in nature, and the response must be coordinated across borders. Governments, scientific communities, and private organizations need to work together to ensure that we are ready for a supervolcanic event. This includes developing shared resources for monitoring, creating joint response strategies, and investing in research aimed at mitigating the long-term effects of an eruption. While geoengineering solutions have been proposed, they remain speculative at best. Ideas such as pumping water into magma chambers to release pressure or artificially cooling the planet to counteract the effects of volcanic ash have yet to be tested on a large scale. Some scientists argue that such attempts could backfire, making the situation worse. For example, injecting water into a magma chamber could increase the risk of triggering an eruption rather than preventing one. Nonetheless, some scientists continue to explore other radical solutions. One such proposal involves using deep-sea mining technology to tap into geothermal energy beneath the Earth's surface. By extracting heat from these geothermal reservoirs, it may be possible to prevent the buildup of pressure in supervolcanoes, but again, the risks of tampering with these volatile systems are unknown. There are many unknowns when it comes to the potential impact of such interventions, and the possibility of triggering unintended consequences cannot be ruled out. In the absence of a perfect solution, the most reasonable approach for now is continued monitoring and research. The more we understand about these supervolcanic systems, the better equipped we'll be to respond if disaster strikes. But even with the best preparations, it's likely that the world will be forced to adapt to a new reality in the wake of an eruption. Supervolcanoes may remain dormant for now, but the risk of them awakening continues to loom in the background, a reminder that the forces beneath the Earth's surface are far more powerful than anything humanity has ever faced. Looking at past volcanic eruptions, the scale of destruction is already staggering. However, the eruption of a supervolcano would dwarf even the largest historical eruptions. For instance, the eruption of Mount Tambora in 1815, while catastrophic, released only a fraction of the materials that a supervolcanic eruption would. Tambora's eruption led to the year without a summer, causing widespread crop failure and famine across the northern hemisphere. A supervolcano's eruption, however, would likely release far more ash and gases, spreading the effects far beyond regional borders. A cooling effect on the global climate could last not just 1 year, but for decades, exacerbating the situation and making recovery even more difficult. An eruption of this magnitude could also lead to a collapse of the global financial system. The interconnectedness of economies today means that disruptions in one region can quickly cause ripple effects across the world. In the case of a supervolcanic eruption, international trade would come to a halt. Transportation would be hampered by ash clouds, and global financial markets could face panic as businesses, unable to operate in a volcanic winter, start to fail. With food supplies scarce, nations would turn inward, hoarding resources for survival, potentially triggering conflicts as countries struggle to secure their own resources. The fragility of modern society in the face of such a disaster cannot be overstated. While we have made incredible advances in technology and infrastructure, a supervolcanic eruption would likely expose the vulnerabilities of these systems. Our dependence on energy, technology, and global trade means that a sudden shift in these systems could lead to catastrophic consequences. Without the ability to produce food locally on a large scale or access critical resources, billions of people could face extreme hardships. In the long term, recovery would be a monumental challenge. While smaller eruptions in the past have caused lasting changes to regional climates, the aftermath of a supervolcano could change the planet's climate permanently. The cooling effect could reduce agricultural productivity, limit biodiversity, and reduce the Earth's ability to support life as we know it. Furthermore, the health effects of such an eruption would be far-reaching. Beyond respiratory illnesses caused by the ash, studies have shown that such an eruption could cause cardiovascular issues and increase the risk of respiratory diseases globally, particularly in heavily populated areas. Another major concern is the impact on the world's oceans. Supervolcanoes have the potential to release massive quantities of sulfur dioxide into the atmosphere, which could then combine with water vapor to form acid rain. This acid rain would fall on the world's oceans, potentially disrupting marine ecosystems, harming aquatic life, and affecting the global food chain. Fisheries, which many countries rely on for food, could collapse, further exacerbating the food crisis. Meanwhile, the pressure to address this issue grows. Researchers continue to work on ways to predict supervolcanic eruptions with more accuracy. Understanding the signs that might precede an eruption is critical, as it could provide the early warning necessary to mitigate some of the most devastating effects. However, the problem is that the geological processes that govern supervolcanoes are still not entirely understood. The timeline for these eruptions can stretch across millennia, making it incredibly difficult to pinpoint exactly when the next eruption might occur. One of the most valuable tools scientists use to track volcanic activity is seismic monitoring. By measuring the frequency, location, and magnitude of earthquakes, researchers can sometimes detect changes in the magma chamber beneath a supervolcano. However, these earthquakes don't always indicate an imminent eruption. Sometimes, they could simply be a sign of magma moving without leading to an explosion. This is why predicting eruptions is such a challenge, and why some experts are cautious in giving an accurate forecast. Even with all the advancements in seismic monitoring and data collection, predicting the eruption of a supervolcano still remains an enormous challenge. In many ways, scientists are working blind, relying on data from past eruptions and geological models to make educated guesses about what might happen in the future. The data we have is often decades, if not centuries, old, and while it's helpful, it's not enough to provide a concrete timeline. Interestingly, some scientists believe that there are clues hidden in the behavior of other volcanoes. For example, smaller eruptions or volcanic activity in nearby areas could be signs that the pressure is building, and a supervolcano may not be too far behind. However, there's no definitive pattern to these events. This adds to the unpredictability of supervolcanoes, making it difficult to determine whether we're at the beginning of a longer, dangerous cycle, or simply experiencing another phase of dormancy. In the case of Yellowstone, one of the most famous supervolcanoes, there have been reports. Despite these uncertainties, some researchers argue that it is only a matter of time before we see an eruption of this magnitude. The historical record of Earth shows that supervolcanic eruptions happen more frequently than we might think. The last major eruption at Yellowstone occurred about 640,000 years ago, and while it's impossible to say when the next one will come, some experts believe we are overdue for another eruption. As a result, monitoring efforts have ramped up in recent years, as scientists seek to understand the underlying causes of supervolcanic eruptions. In response to the growing concern, there has been increasing interest in technological solutions to help mitigate the effects of a supervolcanic eruption. Some ideas have been proposed, such as using technology to cool the magma chambers or manipulating volcanic gases to reduce the impact on the atmosphere. However, these solutions remain speculative at best, with little research yet conducted on their feasibility or potential risks. The magnitude of a supervolcano's eruption is not the only challenge. Its long-term aftermath is something no modern society has ever had to face. The cascading effects on ecosystems, global weather patterns, and human health would be profound and unpredictable. Even though we can only speculate on the full range of outcomes, it's clear that the destruction would extend far beyond the initial eruption. A key factor in the aftermath would be the environmental changes resulting from the massive release of gases, including sulfur dioxide. As it reaches the upper atmosphere, sulfur dioxide would mix with water vapor to form a dense veil of aerosols, creating a global cooling effect known as a volcanic winter. This phenomenon could persist for years, even decades, drastically altering the climate. The temperature drop would disrupt weather patterns worldwide, including those crucial to agriculture. In regions dependent on stable weather, crop production would collapse, leading to widespread famine. The planet's food supply chain would become increasingly fragile, affecting billions. During this climate shift, ecosystems across the globe would struggle to adapt. Species that rely on consistent climates, such as certain crops or migratory animals, would face extreme hardship. The sudden changes in temperature could lead to mass extinctions, disrupting food webs and threatening biodiversity. For humans, this loss of biodiversity means a drastic reduction in available natural resources, further compounding the agricultural crisis. Not only would food be scarce, but the materials we rely on for industry, such as timber and raw minerals, would also be harder to find. In this scenario, recovery would not only take decades but potentially centuries. This scenario prompts the question of how humanity would respond. Could we adapt to a drastically changed world? Some might argue that humanity's ingenuity would find a way. We would likely turn to technological innovations, alternative energy sources, and new agricultural techniques to survive. Concepts like indoor farming, vertical agriculture, and lab-grown meat could become more mainstream, potentially providing a lifeline for populations that can no longer rely on traditional farming methods. However, implementing such measures on a global scale would require cooperation between nations, something that is often difficult to achieve, especially in the face of widespread panic and uncertainty. The response would not only involve technology and science but also diplomacy. Countries would be forced to work together in the face of a disaster that knows no borders. Resource sharing, collaboration on food security, and ensuring access to energy sources would require a level of international cooperation that the world has not yet seen. Governments would need to put aside national interests and focus on the survival of humanity as a whole. But history has shown that in times of crisis, the opposite often happens. Nations turn inward, hoarding resources and seeking to secure their own survival at the expense of others. In the event of a supervolcanic eruption, this tendency toward nationalism could only exacerbate the global crisis. Social unrest could spread quickly as resources become scarce. As people fight to survive, cities could become chaotic, leading to political instability. Governments might struggle to maintain control over their populations, especially in areas hardest hit by the eruption. Even in regions far from the eruption site, the breakdown of supply chains and agricultural collapse would create severe economic and social stress. Cities would see massive waves of migration as people flee from famine and the crumbling infrastructure of their home countries. In such a scenario, the social fabric of many nations could be torn apart. What would be even more daunting is the long-term nature of the crisis. Supervolcanoes don't simply cause immediate destruction, their effects linger for years, and their influence on the planet's atmosphere and climate would remain far-reaching. It would take time for the planet to recover from the cooling effects, and during that time, survival would depend on our ability to adapt and innovate quickly. Scientists and engineers would need to find ways to preserve food, create stable habitats, and maintain functioning societies in the midst of this upheaval. While our technology today is far more advanced than that of past generations, the scope of this challenge is unlike anything we've prepared for. It's true that we've learned valuable lessons from smaller-scale natural disasters, but those events have been localized in nature. A supervolcanic eruption, by contrast, would affect the entire globe, making the coordination of disaster response on a global scale a monumental task. Even the most advanced technologies, such as satellite imagery, AI-driven climate modeling, and drone-assisted crop monitoring, would have limitations when it comes to mitigating the impact of such a massive event. Thus, understanding the true potential of supervolcanoes means acknowledging the limits of our preparedness. Despite all our advancements, our current systems are designed to deal with localized disasters, not planet-altering events. The problem is compounded by the fact that supervolcanoes are nearly impossible to predict with complete accuracy. We may be able to detect signs of activity, earthquakes, ground swelling, or gas emissions, but determining when an eruption will occur is still an elusive puzzle. This unpredictability makes it even more difficult to plan for a global response. How do we prepare for something when we can't say for certain when it will happen? Governments and scientists are left grappling with a dilemma. They must prepare for a catastrophe without knowing if it's around the corner or still millennia away. The urgency is real, but the timeline is uncertain. And as a result, the lack of concrete action can lead to complacency, a dangerous mindset when it comes to such an unpredictable and potent threat. At the same time, scientific exploration of supervolcanoes is more important than ever. By understanding the underlying forces that drive these eruptions, scientists can better anticipate future risks. New research into the dynamics of magma chambers, seismic activity, and geothermal systems can provide us with the tools we need to better understand the behavior of these immense natural forces. By collecting and analyzing more data from supervolcanic regions, researchers can continue to refine models for eruption prediction, even if the exact timing remains uncertain. Some scientists are also working on ways to actively manage the risks posed by supervolcanoes. One such approach involves creating controlled pressure release mechanisms, methods by which magma chambers might be slowly vented to release pressure before it can build to a dangerous level. This idea, however, comes with significant risks. Altering the behavior of a supervolcano could provoke an eruption instead of preventing one. For this reason, many of these ideas remain in the conceptual stage, requiring further research and testing before they could be considered viable. In addition to these efforts, the study of past supervolcanic eruptions can offer critical insight into how the Earth responds to such colossal events. By examining geological evidence from previous eruptions, scientists can develop a better understanding of the long-term impacts of supervolcanic activity. For example, the eruption of the Tobas supervolcano around 74,000 years ago is thought to have triggered a global cooling event, drastically reducing the human population. Understanding the effects of such events on human history can give us a clearer idea of what might happen in the future. Despite the enormous challenges, humanity has always found ways to overcome seemingly insurmountable obstacles. The question is not whether we will survive a supervolcanic eruption, but how we will adapt to the new world it creates. By fostering cooperation, enhancing our technological capabilities, and improving our preparedness, we can give ourselves the best chance to not only survive but rebuild in the aftermath. As we reach the end of this exploration into the unpredictable and colossal force of supervolcanoes, it becomes clear that we face a daunting, yet undeniably important, challenge. Supervolcanic eruptions, though rare, hold the potential to reshape the Earth in ways we have yet to fully comprehend. Their immense power and global consequences demand our attention, not just from a scientific perspective, but as a species committed to survival and resilience. While we cannot control when or if a supervolcano will erupt, we can control how we prepare for it. Understanding the signs, improving our monitoring systems, and developing strategies for mitigation are all essential components in navigating this threat. In many ways, our survival will depend on our ability to act collectively and decisively, both before and after an eruption occurs. The technology and strategies needed to prevent, or even predict a supervolcanic eruption are still in their infancy. But the more we learn, the better equipped we will be to deal with these catastrophic events. Even if a supervolcano doesn't erupt for centuries, the threat is real enough to warrant immediate attention. With the right investment in research, collaboration, and disaster preparedness, we may yet be able to safeguard our civilization against the wrath of nature's most destructive force. Ultimately, what we do today will determine our ability to face the challenges of tomorrow. The stakes are high, and the potential consequences are enormous. But humanity has a long history of facing seemingly impossible challenges and emerging stronger. If we take the lessons of the past to heart, and put in place the necessary measures, we can ensure that the next supervolcanic eruption doesn't spell the end of humanity, but rather, a new chapter in our story of resilience and survival. In the end, the true question isn't whether a supervolcano will erupt, but whether we, as a global community, are ready to face it when it does. Will we be proactive or reactive? Will we choose collaboration or isolation? The answer to these questions will shape the future of our planet and the survival of generations to come. Only time will tell if we are prepared, but one thing is certain: the clock is ticking, and the window of opportunity to act is narrowing. Now, more than ever, the time to prepare is now.